Dear children, today we are going to see one of the theorem of 10th class in the circle unit. So first we shall see that what does it states. It states that if a radius is drawn at a point of contact, then it is perpendicular to the tangent. It means if there is a circle and there is a tangent, they both meet at one point, that is called as a point of contact. So he says that if a radius is drawn to the point of contact, then it has to be perpendicular to the tangent. So again I am going to repeat the statement. Radius drawn in a circle, a radius drawn at a point of contact is perpendicular to the tangent. So it is a theorem which we have to prove now. Okay, let us start. First let us see the statement of this theorem. So it states that the tangent at any point of a circle, it means if there is a circle, the tangent at any point of a circle is perpendicular to which? It is perpendicular to the radius at a point of contact. So if a radius is drawn from the center to the point of contact, that will be perpendicular to the tangent. This is what the theorem states. Now, so whenever we start a theorem, we start with the diagram. So in the diagram, so what we have considered, there is a circle with a center O and there is a tangent, name it as xy. Then there is a radius, that is OP, here we have drawn. So that dotted line that comes later on in the part of construction. So basically here the given data, from the given data we are able to draw this much of diagram. Here O is a center, P is a point of contact and xy is the tangent. So here it is data. Consider a circle with center O and xy is a tangent, OP is a radius and P is a point of contact. Then to prove, what I need to prove? I need to prove that here if it was a circle, this was a tangent, it was a radius, here it is xy, x and y, and here this OP is what? Perpendicular to this xy, that I need to prove. So in order to prove that, we have to have a construction, and in that construction what we are going to do is, here we have considered take a point Q on xy. We were having this tangent. For this tangent we have taken a point Q on that xy. You can take anywhere apart from that point of contact. So here we have taken the right side. So that point we have considered it as what? We have considered it as Q. So then after that join OQ. We have joined here. This dotted lines indicates that construction, that is what extra part, that is OQ. And again here OQ cuts the circumference at a point R. This line which we have joined from O to Q, it is been intersecting the circumference at a point R. Then the last part of a theorem, that is proof. It will be divided in two parts, that is statement and reason. And the first thing what we have written here is that OP is equal to OR. Here I am going to show on the figure that OP is equal to OR. This OP is equal to OR, what might be the reason behind why we have written that OP is equal to OR? And that is radii of same circle. You can observe that here from O to P and from O to R, we can see that it is nothing but it is a part of what? The same circle, that is nothing but it is the radii of same circle. Then the next one, here OR is less than OQ. Find from the observation of a diagram, here O is there, here point R is there, here it is Q. So from the observation we can see that OR is a part of a complete line OQ. So from that point what we can say that here OR, this part OR is less than the complete length, that is OQ. So for this we can give the reason that according to the axiom number 5 of Euclid, that is whole is greater than the part. Then at last what we are going to write that here in the second step we have written that OR is less than OQ. Here in this place we know that OR is also is equal to OP. Here in place of OR I am replacing by OP. So directly what I am going to write is that OP is less than OQ, because here we have mentioned that OP is nothing but which is equal to OR. So in place of OR we have written OP. So now it comes that what this OP is less than what OQ. Now, so what is the main theme of this theorem is that in order to prove that it is perpendicular, that what this OP is perpendicular is nothing but the line will be perpendicular if only if it is the shortest distance from that center point. So now we have proved that this OP is the shorter than any other line segment joining O at any point on XY. If you are taking any so many numbers of the lines, that is from O to this line XY, then also this line will be shorter than those other lines. So from this work we can say that shorter distance is nothing but that line which makes a 90° to the base. So last week are saying that since it is shorter distance, that is a shorter distance, so we are able to tell that OP is perpendicular to XY. So by this we have proved that this OP, which is a shorter distance from the point O to the point of contact P, that is the shortest distance. Since it is shortest distance, we can say that it is nothing but OP is perpendicular to the XY. So this was all about the theorem.